Welcome to this demo of Java Under the Hood, in which I will demonstrate the use of a reference type by creating an instance of a custom class. So far I've only created standard objects of type random. The way I represented those objects in the heap was basically by drawing an empty gray shape that did not really represent its internal representation in memory. A question that remains unanswered is thus, how does an object really look like on the heap? Let's find out in this demo. The code I'll use consists of two classes. First of all, a class that defines a rectangle with four properties, x and y, that represent the coordinates of the top left corner of the rectangle, and the height and width properties. So a very basic class without any methods. The rectangle.java file contains the definition of the class. The other class contains the main method, in which a rectangle object is created. This class represents the client code. Client code is simply put the user of a given class. In this example, the client code uses a rectangle class in order to create an instance of it. Let's see what happens in memory when we execute that statement. I start by setting up the stack frame of the main method with its arguments parameter. Then, what happens when an instance of rectangle is created? Well, the same as with the creation of any object. First, the declaration of local variable rect1 results in a variable being stored in a local variables array. In this case at the second position, since the first position is already taken. Then, new rectangle. The object is created on the heap at some address. Here I use fictional number 1000. And finally, the assignment operator in the statement assigns the address of the object 1000 to the local variable rect1. So exactly as I demonstrated earlier with the random objects. But what is created? How many bytes are allocated for the object on the heap? In short, what does the rectangle object really look like? Well, in order to figure that out, one has to examine the Java definition of the rectangle class and look for non-static properties defined in the class. In our example, rectangle has four of them: x, y, height and width, each of type integer. Then the general rule is that a variable is allocated for each non-static property, so one integer for x, one for y, one for height and one for width. So 4 properties times 4 bytes per integer is 16 bytes in total. Voila! That's it. See you in the next video.